Alright, hello guys. Welcome to another video. Today we'll be talking about number 62, unique paths. So this problem is a medium problem, and it says a robot is located at the top left corner of a m times n grid, marked start. So this grid right here. The robot can only move either down or right at any point in time, and the robot is trying to reach the bottom right corner of the grid, which is the star, and it asks you how many possible unique paths there are to this problem. So this is the input-output for this image. As you can see, there is 28 different possible paths. So let's look at this diagram here. So we have this grid that we took from the problem. So what our approach here can be is that we want to sum up the number of ways to get to the position in the grid by adding the number of ways to get to the grid on the top and the grid on the left. So right here, what I mean is, so we want to get here, which means it needs to sum up this square and this square. And this square means it needs to sum up this square and this square, while this square wants to sum up this square and this square. So we do that from here to here, and we return this value. So let me demonstrate what I mean. So at start, there's always one way, so it's 1, and this is 1 because there's no above row, like there's nothing here. So this whole row is going to be 1. And then this whole column is going to be 1 because there's no column here. But here is the interesting part. So this one, since there is a value above and to the left, you add those two together, which gets you 2. And this is 3, 4, 5, 6, 7. And then here, it's these two values. So 3, 6, 10, 15, 21. And here, this is the value we're returning, and we just add these two together, so 28. And 28 is our final answer, which is correct. So in this problem, as you can see, there were 3 situations. So one was when I is bigger than 0. By I mean the row. When I is bigger than 0, and j is bigger than 0, and when j is bigger than 0, so from here to here, and when I was bigger than 0, so from here to here. Alright, so these are the 3 possibilities, and this grid is already predetermined, so it's just 1. So let me write the 3 possibilities here. Oh my god. So when I is greater than 0, and j is greater than 0, or when I is greater than 0, or when j is greater than 0. So these are the 3 possibilities that we need to look out for, and the data structure I'll be using today is a int array, or sorry, 2D int array. Because a 2D int array can resemble this picture pretty clearly, and it'll be very straightforward to learn. So right here, let's go back to the problem, and let's start coding. So at first, I'll instantiate this 2D int array. I'll call it DP because this problem is a dynamic programming problem. And so you want to set the size as m and n, obviously. And then here, you want to preset the value at 0, 0 to be 1 because that value is predetermined. And now we can actually start iterating through our array. So let's lessen m, and then whoops, I plus plus, and then for and j is equal to 0, j is less than n, j plus plus. Alright, so inside here we can start writing our conditions. So if I is bigger than 0 and j is bigger than 0, or if only j is bigger than 0, or if only I is bigger than 0. So when it's oh wait so when it's I is bigger than 0 and j is bigger than 0, there will be a grid above and a grid to the left. So what we can do here is when that happens, it's actually dp of I and j is adding dp of I and j minus 1 plus dp of I minus 1 and j. And this is because when you're here, you want to add up this value and this value. So this is j minus 1 and this one's I minus 1. Alright, so now for when j is larger than 0. So when j is larger than 0, then it would be this situation right here. So then there wouldn't be a grid above, so it can only add from the left. So what we need to do here is when j is larger than 0, then this I and then j is plus equal to dp in I and then j minus 1. Alright, now for the last condition. So this last condition is when only I is larger than 0, so this part right here. And because there are no left grids this time, we can add from above, so from like here. So our code would look like dp I and j is plus equal to dp at I minus 1 and at j. Alright, so now we have iterated through our array and added all our values up. So what we need to do is we just return the last value in the 2D array, which is n minus 1 and m minus 1, because this gave you the actual length. And if you want to get this one, the index is always 1 less than the actual length. So we have to subtract 1. And this is the code for the problem. So as you can see, we got the right answer here. So we're just going to submit. And we passed. And I just want to clarify for here, you don't have to do m or n. What you can do is dp.length minus 1 or dp at 0.length minus 1. That's all fine, same as here in the for loop. But because these two parameters are only one letters, it was easier. That's why I used it. So now that we can analyze our time complexity here. So right here we have a for loop, and then we also have a for loop inside of the for loop, which is nested. So the time complexity is O of n squared. And right here we're actually using a little bit of extra space to solve this problem, but that's fine because it still fits within the problem's constraints. And yeah, that's how you do this problem. Make sure to watch some of my other videos, and if you're interested in more dynamic programming videos, make sure to check out my playlist. Yeah, thank you for watching today, and make sure to like and subscribe.